Okay, what we're going to do here is going to go through a few of the products that we have here at CapLink for our Linqstat materials. Customers always ask what the difference is in the volume conductivity, what's the resistivity of the materials, and then how do you measure it? Now the way that we measure it for the information that we have on our data sheets and for the information that we post on our website is we just use a standard multimeter. And the multimeter then gives a value that's given out in ohms. And the way that this works is then we take the measurement here. The measurement that we have ultimately on the products is a measurement in ohms per square. The ohms per square is used for the surface resistivity because the surface resistivity is supposed to be independent of the thickness of the material. So I'm going to start this video by first showing the differences in the materials and then showing the differences in the thicknesses. So if you look at this product here, this one here is the MVCF-40012. The first number always gives an indication of what the thickness is going to be. Always check the specifications on the data sheet for what exactly the thickness is, but you can see that it comes close to where the thickness is in mils. For example, this is 4 mil, this is 3 mil, this is 4 mil, this is 3 mil, and you can see that the difference is MVCF-4, XVCF-3, XVCF-4, XVCF-3. So if I measure this one here, which is the MVCF-4 series products, and you measure it with a digital multimeter, what you'll see is that the value that we get for the thickness of the film is then, as we expect, 0.1 millimeters, which is 100 microns, which is 4 mil thick. If we then go over and we take an example of this product here, which is the XVCF 3 mil, this one isn't exactly 3 mil. 3 mil would be 75 microns, or 0.075 millimeters. And you can see that this product here that we have, this product here is a little bit thinner than that. So this is actually 0.07 millimeters, just under 3 mils. And you can see on the data sheet and the information that we give that it is indeed 0.07 millimeters. So you can always check it with the product data sheets and the specifications for what the thickness is. When you're starting with your application and you want to have a certain thickness of the material, you can always check with the product that generally pretty close to the first number will get you in the ballpark for the thickness. The second number that's on the data sheet is the surface resistivity. As I mentioned, the surface resistivity is independent of the thickness, and the way that we measure that is across the surface or the plane of the Linqstat material. If we take this material here, this is the MVCF. This one here doesn't give the surface resistivity in the product name. But you can see that if we take the measurements that we do, and you can always ask us for the values of this data. If we first take the distance of 10 centimeters, so you see from 1 to 11, it's a distance of 10 centimeters. And on the multimeter, what we see is a value of 16, 15 to 16. There it goes up to about 20. We take 3 points at 3 different points, and we take the value of the multimeter after about 5 seconds or so, once it stabilizes. So here you can see that the average value is about 15 kilo ohms. Kilo ohms then means 15,000 ohms per square. That's what puts this product into our MVCF range of material for medium conductivity. The actual value that we post on our data sheet, however, though, is the distance taken at 1 centimeter or 10 millimeters apart. Doing this same test, and just at the distance of 1 centimeter, you then see that this has a value of close to 12 kilo ohms or 12,000 ohms per square, and that's the value that we'll then put on the data sheet for these materials. If we carry this out to the other materials that I have here in front of me, you can see that we also have the XVCF-30009 BT150S. It's this number right here, this 150, which is really going to tell you what the surface resistivity of the products are. So again, the values that we test are the values at 10 centimeters, and here you see that the value comes to about 227. But the value that we actually record on the data sheets is a value that's 1 centimeter apart. If you look at 1 centimeter apart, what we end up with is 133, 135, and the values are close to 150. Because of the particle distribution of the carbon that's in the conductive film, it's difficult to have a completely, precisely, reliable number that's repeatable every single time. But in terms of expectations and in terms of specifications, the 150 to 123 are in the same range of what we expect for this material for the conductivity. So the value that's given is after a number of tests, and the value is 150, and this is the value that we then propose to our customers. Moving up to the next product on our list here, this is the XVCF. And this one here is, you can see the 4 mil, and then it's BT500S. So the data that we generate, again, at 10 centimeters, gives us around, here you can see 0.39, but this is in kilo ohms. So the number that we're actually recording here, if you put that into ohms, is about 386, 390. Taking this value down at the 1 centimeter distance again, you'll see that the value here says 230. 230 then puts it below the 500S, which is the number that we have here on the data sheet. Moving up to this material here, this is the XVCF-3009BT. Again, we're looking for something below 500 ohms per square. The distance of 10 centimeters, we get about 0.83, which translates to 830 ohms per square. Doing this at a distance of 1 centimeter brings us back into 0.38, 0.39, which in ohms then turns out to be just under 400 ohms per square. So that's the way that we measure the volume conductivity of our materials. Just to give you an example of how that compares to a conductive material, if you take this thin strip of copper foil, also a product that we sell under the Linqstat name, copper, as you would expect, is a conductor, so the value that you would expect in ohms for resistance is 0. And if you look at the multimeter, you can see indeed that the value that you get for the copper strip is 0 ohms per square, so all the values of all these conductive films are relative to a value of 0. Hope you've learned something, and if you'd like to take a look at our website, you can see more information at www.caplink.com. Thank you very much.